1.
These two RCA plugs are shorted to the output of the function generator. So this generator is driving the same signal to these plugs. I plug them into the input of the LCR, and then I use my meter to check both of the outputs. So I have one meter that's connected to here, and I bounce back and forth between the two channels as I set my frequencies and my levels. So what I always do is I start with set the meter at plus 10 dB and I check 1 kilohertz. So I go here and I bring up 1 kilohertz. Sorry, it's not adjusted in frequency yet, so we get it all adjusted. So now we're set at 1 kilohertz and I zero it out. And that is the center point for RIAA references of everything. So we go from left channel to right channel, and we are dead on. I can't tell you there's even 1/10 of a dB difference between the two. This is as accurate as anything's going to be. Now what I usually do from there is I check the high frequencies. So I go and I switch my function generator to 20 kilohertz. And then, now 20 kilohertz is going to be 20 dBs down about from 1 kilohertz. So now I have to move the ranging down to -10. And you will see that I'm set at about a little bit over plus 1.5 dB over 0 referenced to what it should be. And that's how I've adjusted these things for now for many months. This is what customers prefer. They prefer a little bit of a bright sound. So then what I do is I go to the other channel and I check, and we are dead on here. Possibly 1/10 of a dB difference at no more than that. So then what I do, now because of this being a special situation, I go back to 1 kilohertz. So let's range this. Set it back at 1 kilohertz. And now I want to know, is there any kind of amplitude anomalies? So we're at 1 kilohertz at plus 10. Now I will adjust it down to 0 dB and make sure we're channel matching between the two channels. So I'll get this dialed in, and then I go from left channel over to right channel again, and we're dead on. And just to be sure, I go down another decade down to -10 dBs, and I switch the channels again, and we're dead on. We're still at 1 kilohertz here, so we're acting like a sound at 1 kilohertz is decaying down. And I even, in this case, took this down further, -20 dBs. And I switch channels. And as you can see, the meter is always holding at 0 dB. And even down into -30 dBs, where you're starting to push down into the dynamic range of most LPs. It's very sensitive here. Very, very, very sensitive. So this is about where the noise floor of most LPs is riding. And as you notice, we're on, and you go here, and we're on again. There's a little bit of drift in here, and that's because we're down in the noise floor, getting down in the noise floors of the units. Let's check again. We are within 1/4 dB down here. Okay, so what I do is I go to another frequency. So in this case, I'm going to switch this to 500 hertz. So now we're getting down into the upper levels of the mid-range. So that's about 500 hertz. Go back to 0 dB. Channel to channel. Dead on. Down another decade to minus 10 dB. Get this dialed in. Channel to channel. Dead on. Now we go down into minus 20 dBs. Channel to channel. Dead on. Now I'm not going to bore you. I did this at 300 Hertz. I did this at 200 Hertz. Same method. We can go down to 100 Hertz, where your base frequencies are. Let's get this set up at 0 dBs. Here's 100 Hertz. Channel to channel. Pretty dead on. Maybe about a 20th of a dB off at 100 Hertz. Maybe a 10th. Don't know. Okay, we go down another decade. Channel to channel. So now we're at 100 Hertz at minus 10 dB. Dead on. Dead as a doornail on. Go down again to minus 20. Did I say minus 20 before? That was minus 10 we did. Here's minus 20. Not sure what I said, but anyway, here's minus 20. Maybe a 10th of a dB out. Okay? And so let's go down into about the lowest frequency anybody hears with any kind of accuracy, you know, with any kind of realistic listening. We can go down into, let's bring this down. Let's go to about 30 Hertz. So we'll bring it up. So here's 30 Hertz. So instead of going down from 0, we'll go from 30 Hertz to minus 20. So we're going from minus 20 at 30 Hertz, channel to channel. Maybe a 10th of a dB off, maybe a little more. We bring it up. So now we're listening to 30 Hertz at minus 10 dBs. It's very sensitive here. You're running into areas of getting close to 60 dBs of gain in this area because of the RIAA filter and every way everything works. So there we go. We're at 0. Maybe a 10th of a dB out or less. Okay, so now we're going to 0 dBs level at 30 Hertz still. Very sensitive. I got a little shy of 0, so let's see what we're like. Okay, and it's a little more shy of 0. That might be a 10th of a dB out. 10th of a dB out at 0 dB at 30 Hertz. And I usually test 20 Hertz. We can go and we won't decade down into 20 Hertz, but let's just go see what 20 Hertz is like. I usually bump 20 Hertz up to plus 10. So when you're playing the 1812 Symphony and you got all the explosions there, so you know there's your high level 20 Hertz. Dead on, dead on. Let's skip down 20 Hertz. Let's skip 10 dB and let's go 20 Hertz down to minus 10 dBs. We'll zero it out. Extremely sensitive because we're at the bottom end of the frequency spectrum and the highest gain. Okay, let's see. Get that adjusted a little bit better. It's very picky right there. 20 Hertz. Dead on. Dead on at minus 10 dBs. And to finalize this, we'll go minus 20 dBs at 20 Hertz. Really touchy to do. And plus we're starting to get down into where noise floors interact. Okay, there we are, zeroed out, and right channel, and we're maybe right channel might be a tenth of a dB off or so. It's drifting around a little bit because of noise floor and stuff like that, because we're way down low. So anyway, that's it.